Welcome to Hadoop Exam Learning Resources. In this session, we are going to cover the big data. What exactly is the big data? What is the problem with the big data? And how using the Hadoop framework we can solve this problem. So we'll pick up as a sample one problem statement of the big data and we'll try to solve the same problem using the Hadoop framework. So how Hadoop framework helps in. So while doing this, we will learn two main component of the Hadoop. That is one, the first one is the Hdfs, that is Hadoop Distributed File System, and second is the MapReduce framework. So let's start with the problem statement. Okay, so let me clean out the screen here first to understand the things. Okay, so what exactly is the big data means? Okay, so what I suggest, you literally take a meaning of big data as a big. So people says there are not any linkage or not necessarily there is a link between big and data something, but I would suggest that it is solved the big data problem for the Hadoop framework. So let's assume it, you have a 100 GB big file. Your file size is a 100 GB. What it contains, this is the stock market price of last 50 years of all the global securities. Okay, last 50 years. So what my file structure is, there are four columns. First one is stock symbol, second is date, third is previous day price, and today's current price. Okay, same day for which date is provided, current day price. So let's take a first symbol is IBM. Date for this is 1st January 1970. Okay, and the previous day price was $100, and that particular day the price was $90. So this is my file structure. CSV file, you can just assume comma separated file. But the problem here is the size of the file is 100 GB because it contains all the global securities, like from India it is Infosys or TCS, something like that, or from Google, all the companies, and the stock prices from, if they exist in last previous history, whenever there is exist, there are data with the price of 90 or whatever you can say, 90 and 80. This price trends actually goes, this is 70 and this is 85. Okay, so there is a 85 or 90 kind of this file you have. What exactly you wanted to do in this problem statement, first you have to calculate the return of every day from this whole file. So what happens is, exactly to calculate, let's assume these are the four columns. So I would say these are A, B, C and D, four columns. So my calculating return formula is C minus D by C multiplied by 100. Okay, this will give me the percentage return. So in first case it would be 100 minus 90 divided by 100 multiplied by 100. So it gives me 10% return. So minus sorry, other way around, D minus C divided by C. So this is 90 minus 100 divided by 100. So it's minus 10% return of the stock on that day. Similarly, we would have calculated minus 6%, whatever, because I'm just randomly putting here, plus 6% return here. So calculated is a 5% return. Okay, something this kind of return you have calculated, and for each stock symbol you want to produce the graph from 1990s to like 2014. What is the trend of IBM stock, like from $0 to whatever $1,000 price? If I will draw the graph, it might go like this. So to draw this graph from this data, we have to process the complete 100 GB file. If we write a Java program to do this calculations of 100 GB files, because this file contains 100,000 million records. Okay, 1,000 million records, and approximate time to solve this problem, it takes 72 hours from your normal Java multi-threaded program. So it takes almost 3 days to produce such graph to you. Like if you do the whole processing on normal Java or Python programming or any calculation engine you use, which is legacy or something now. So this is the what exactly is the my two problem here is 100 GB file. It's okay, 100 GB is not that big file, but if let's assume this file size is 1 terabytes, which contains more data. Suppose let's assume this file is rather than 100 GB, it's a 1 terabyte file, and this so opening this file, storing this file, these are the big problem, correct? So this processing this file is my second problem, but first problem is where to store such a big file. Okay, and how I cannot manually open this file if I want to see the data or something. So, and not single operating system can easily handle such a big file, because this your generally hard disk size is 1 terabyte, 2 terabytes or something. So putting such a big file, many files would be a problem. So that is my first problem, that is called big data problem. So any system which cannot handle your data volume or size, that is called the big data. So this is basically, it varies this term with place to place or situation to situation. So 1000 GB file is a big data file, and second problem with the same thing is how to process this 1000 GB file. This is so huge file which takes my problem to solve 3 days using the norm of highly concurrent Java program. Still it takes 3 days, and no business will accept such a huge legacy time. So to solve such kind of problems, there is a new framework. Okay, it's not new framework. If you know, this is now almost completed 10 years Hadoop framework in the market. So to solve such kind of problem, there is a Hadoop framework. So let me clean out the screen. Okay. So Hadoop framework is made of mainly two components. I would first say Hdfs, second is a MapReduce. Okay, so we'll first see the problem of Hdfs. So this Hdfs solves the problem of your storage. MapReduce solves your problem of processing. So like Java code, to calculate the your return, which we have done formula C minus D divided by something D minus C divided by C multiplied by 100%. This processing is done by the MapReduce, and storage like 1000 GB file to be stored using the Hdfs. So what exactly is Hdfs? Hdfs is a file system which is distributed across the machine. So let's say at the Yahoo, you have Yahoo Development Center or wherever, or any financial organization which works on this, have set up of like up to 50 nodes. What exactly nodes? Nodes is equal to your one computer, you assume it. Okay, so there are 50 nodes to solve your problem. So now you have 1000 GB file. Why don't you divide this file into the block? Like I would divide into the 100 block. Even 100 is not good enough, because I would say it's a 500 blocks. So my each block size is equal to, I would say, 2 GB. Still, it's a huge block size. I would say 5000. Okay, so 512 MB is my block size. Okay, so I have total 5000 blocks of this 1000 file. So what happens is, in the file I have 50 nodes. So each node can occupy 100 blocks of the file. So 100 blocks here, 100 blocks here, and each block size is what exactly? Each block size is 512 MB, some equal to almost half GB. So if you divide your whole stock price file into the blocks, then easily this file size become a very small, not very small, it's a 512 MB, and each block is stored on the multiple nodes. So that's way this is and this is single. If you say this is whole computer, if you all the nodes make equivalent to one HDFS file system, because your file exists on HDFS file system, and each block is file is divided into the multiple blocks. So now the question comes into, like, my file is divided into the 5,000 blocks. So but who keeps this information, like which block is on which node it is located? So there is a called one master node, that is called name node. As its name suggests, it contains the name and location of the each block in its metadata file. Okay, so now benefit here is you have divided your file into the multiple blocks, and it is across the 50 nodes. This file is available, each block is available, and the information is available in this name node, like where and which node which block is located. So that is the here main points comes into the picture. Now Hadoop says, like, if this node goes down, so you have lost where your file is located, this kind of information. But to solve such a problem, there is secondary name node, that is called SNN, that is active. This is active node, and this is passive node. This is second node. So same replica of metadata is also available on this node, metadata, that is called metadata. So like this information, where is the block located, who has the file permission to read, or this kind of information. So exactly this secondary name node is a replica of that primary name node. So this node goes down, suppose, then still this node is available, and it says, like, where is your block is located, this information still available. So now that is the advantage of HDFS file system. So let me clean out again and draw the diagram. So we have 5,000 blocks. My file is divided into the 5,000 blocks, and file size is 1 terabyte or equal to something. Okay, so now there are 50 nodes, up to 50 nodes, correct? So now each node has 100 blocks stored of my file. So now questions comes here, and this is the name node, and there is a backup node. This is not backup exactly, this is secondary name node, this is passive node, which keep in sync with this node, and each data node, and this node is called data node. Okay, keep in mind, this is data node. So this node stores the data, that is data node. This stores the metadata, that is name node. Secondary name node is the backup of that node. So now each node keeps sending the heartbeat of its actively, or whatever information it has. So this whole cluster remain in sync. Now questions comes here, like, if this node goes down, my 100 blocks stored on this node has gone. No, to solve this problem, HDFS also brings in concept of replication. So logically, based on the replication factor configuration, which is by default 3, so your 100 blocks which are exist on data node 1 can also be exist on data node 2, data node 3, and data node 4. Either this is distributed. So like this particular block, which is like a block, I would say I have a block, B block, and C block. Kind of this block of data is available. So A is present on exactly 3 nodes throughout the cluster. So sorry. So suppose this node goes down, still this data is available on two other nodes. So exactly if I would say there are thousands of blocks or 5,000 blocks multiplied by 3, actually there are 15,000 blocks would be stored out of your data, and this whole information is stored by this name node in a metadata directory file. So it will know where the exactly data is located. So that is the way Hadoop solve the problem of storage, okay, using this data node. So keep in mind, this is data node, this is name node, this is secondary name node, this is active passive mode. It runs in the active passive mode. So this goes down, this comes up, or if any data node goes down, still data is available on two other nodes. So here we have considered block size is 512 MB, but logically by default the block size is 64 MB in the Hadoop framework. If you install a Hadoop framework and processes by default the 64 MB, you can change this configuration from the configuration file. So like what kind of size? So this division, the beauty of here is like your whole file, like which is 1 terabyte, you don't have to break into the block to store it. It is the responsibility of the name node or whatever, or any Hadoop component. One of the Hadoop component is responsible to divide your file into the block of size. So that block goes here, that block goes here, something kind of this block goes here, and there is no consecutive 100 block would be on the same node. This is the decision taken by the Hadoop framework which block would go on which node. So this depends on the various things like hard disk space on your data node, processing speed of your data node, location of the data node, what topology you have configured for networking this node. So based on these things, the data is distributed among the all nodes. So that solves the problem of storage using the Hdfs. So this is the Hdfs. There are in depth detail we have to understand about the Hdfs, but as an overview from 10,000 feet top view, you can see like that is Hdfs. So how to configure and many things. So you can go to hadoopexam.com to understand in detail about the full configuration, how it works kind of thing. So full length training is provided on hadoopexam.com, which also provides like certification preparation for Hadoop framework. So now that is about storage. Now let's move to the next part of our calculation. That calculation what we have defined by d minus c, whatever my formula. This is IBM 01011990 is the data price. Previous day price was, sorry, current day price was 90, previous day price 100. So I would say A, B, C and D, these are the variables of this corresponding to this file. So this file is 100 GB for all the stock prices are there, and my formula is previous day minus, okay, so this was previous day price, sorry, this is previous day price, D minus today price as of 1st January, divide by T multiplied by 100, okay, multiplied by 100%. So which is exactly 100 minus 90 divided by 100 multiplied by 100%, which come to the 10%. And we want to process this or do the calculation for the whole file of 1 terabytes, which takes 3 days to finish normal Java concurrent program. So how to solve this problem using the MapReduce? This is the second part of the Hadoop framework, that is called MapReduce. So as you can see, this is map and this is reduce. Here separate, I would say this is sorry, not straight line. I would say this is map phase and this is reduce phase. Exactly what map phases do, it will do the calculations of your Java program and produce the key value. So my key would become IBM 0101 1990 and comma value is 10% minus 10%. This calculated value would be emitted to the reducer. Now responsibility of reducer is to the how many reducers you are running depend on this. Each reducer produces one file. So assume we are running 100 reducer. So the key whatever you have generated Google 01011994 is minus 20%, this kind of return. So this go to the reducer. Now reducer based on the key, the data will go and it will produce the output to the file and it will write the file. So the my final file structure would be like this, divide by, I would say IBM 01011990 minus 10%. Okay, this is Google, whatever date return is minus 10%. Sorry, date and my return is equal to 5%. So this kind of file will be produced out of this, and based on the key, so like it might be possible like there are 1000 stocks, so each file would contain only IBM stocks output. So this is how you like this kind of file would be produced after running the MapReduce. Okay, so how it is generated? So I want to generate this file, okay, using the MapReduce and to process my data which is stored across the cluster in the various block. So that's the come into the picture here. Like I have 50 nodes. This is your name node. Sorry, I'm not putting here the secondary name node. Okay, so this is my name node. This is data node, up to 50 data nodes. Okay, each node contains. So what exactly I have to do? My file is here on each node. So what you have to do as part of MapReduce, you have to write a Java code, or let's assume I'm just taking a consider which calculate this t minus c divided by into 100%. So this formula you can take. So now you have to write a map which produced like in the mapper class. You have to write a mapper class which does this formula. So you read a line IBM date and stock price, current stock price $90 and previous day 100. In the map phase you have to decide what is my key. So this combination would uniquely identify the stock and which date the return. So I would consider this as a key, and to generate the value I have to apply this formula on this data, and this calculation is submitted to each node here. On the each node this calculation is submitted. So now you have 50 nodes and 100 blocks on each node. So your mappers are running on the 50 nodes parallelly on this each node with 100 blocks. So these 100 blocks are processed in 5 minutes. So 5 minutes, 5 minutes, 5 minutes on each node which is in parallel. Even let's assume it not 5 minutes, I'm taking more correct, correct value, like let's say 30 minutes. It takes to process the 100 block. And each are running in the parallel, correct? So you are processing 30 minutes the 5000 blocks as a part of mapper. So now each block has produced this kind of output, stock market and its return value. Okay, so now this output of each node goes to the reducer. Reducer is also runs on the sum of the data node. So data node is also same as a worker node. Okay, so processing run on the data node. So is output of the mapper goes to this reducer, output of the mapper this goes to this reducer, to this reducer, to this reducer. It's combination of this, or each will go accordingly. Okay, so out of 50 nodes, reducers goes to the 5 reducers node, and reducer will do the sorting and producing the output, like each file for each stop symbol. So this like produce like assuming like as many reducer, as many files would be generated. So I would say my IBM, Infosys, because these all are sorted by the alphanumeric, Infosys, Intel, and all stock I start with I will go to this reducer. All stock will start with A, like ABC company, Apple company, or something else goes to this reducer. Company start with B will go to the B, come something kind of, or C also go here, D also go here. Because of data size and everything, it is based on the configuration, number of reducer, many things, it goes to this and this node. So here you have seen the differences. Now your data is already stored on these blocks, on these nodes, and processed by the MapReduce framework. So now you are not sending your data to the like first, like in Oracle database or something, you are working something like first fetch the data, do the calculations, and create the file. This is your process, correct? But here, like, you are not fetching the data, which is the huge volume. What is the big volume? Is the data, and code size is just 100 KB file. Even I am saying too much, like just few KBs file, 10 KB is my Java code. So what we is like Hadoop framework prefer, like rather than sending a data to the processing engine, why not send a processing engine to the like processing sorry okay, so why not to send this processing to what I say, to code to the data, rather than sending a data to code, send a code to the data and process here on each node. So each we leverage the benefit of 50 nodes running in the parallel, and each process runs in the parallel. So 30 minutes to run the mappers and 30 minutes to run the reducers. So like whole process finishes in 1 hour, which was previously taking 3 days to finish the whole process using the single processor. So that is the beauty of the Hadoop framework. So now how this MapReduce works and kind of thing. So this is a different like let me finish out the first one. So there are two versions of Hadoop framework available, Hadoop 1.0 and Hadoop 2.0. So Hadoop 1.0 to Hadoop 1.2.0 drastically changed, like the overall processing framework has been changed from Hadoop 1.0 to Hadoop 2.0. So previously in Hadoop 1.0 there was a job tracker. So the job tracker is the who submits your MapReduce job to each data node. So for processing and storing, the naming convention change, like assume this job tracker and name node is the same. So name node for Hdfs master, and for MapReduce, running the MapReduce, job tracker is the master. Both are running on the master node. So this is data node on which data store, correct? So now my data stored here, then task mapper task has to be run here only. So this is also called task tracker. When the processing is run, processes are run on the task tracker, that is called task tracker. So this processing runs over here, task tracker. So this is runs mapper task, reducer task, and what do you say, yeah, this is mainly two tasks, and in between many things happen, sorting, shuffling, or something. So this kind of in detail we will cover in different session. So this is Hadoop 1.0 architecture, but in Hadoop 2.0 the things has changed to make it better and more performant and supporting more than 10,000 nodes in the cluster. New framework has been introduced, that is called YAM. yet another resource negotiator. So here I'm stopping about this HDFS and MapReduce understanding. So like Hadoop, even MapReduce works with the Hadoop 2.0 framework, but the processing, the way it is processed, like here job tracker and task tracker is here, but in the yarn, this varies. It has changed drastically from this. So that's all about in this session. Before ending this session, what I would suggest you visit Hadoop exam.com. This website is we provide the Hadoop in-depth training on like Hadoop 2.0. Some NoSQL sessions are also included. Some like Pig, Hive also included in this. Yarn we have included in this session. Okay, and many things we are keep adding every now and then in this training session. So you can once subscribe on this session, you can get the all future sessions freely from this training. So we have already reached 7,000 plus subscriber on this training, on Hadoop training. And other than that Hadoop training, we also provide the Hadoop certification material like developer certification, administrator certification, data science certification, HBase certifications. These are the certifications related to the Hadoop. And if you wish to do the certification in the cloud, like Amazon Web Service, we also provide certification material and training material for Amazon Web Service. Other than that, we also have SES analytics certification preparation material. So we suggest please visit at least once and subscribe this hadoopexam.com to get the updates, as well as please don't forget to subscribe this YouTube channel. We keep adding free videos as well in the on YouTube regarding the Hadoop and any other. This is very dominated to the new technologies, cloud, Hadoop, analytics, data science kind of thing. So thanks for listening, and I hope you have enjoyed it, and you will visit the hadoopexam.com and please subscribe this YouTube channel, I would suggest, so you will get regular updates. So thanks for listening, and I'm ending the session here. Thanks.